Right. What are we going to do today? Ninth standard ncert books. We start with chapter 1, number system. Number systems. You know, the first thing we learn is numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It goes on and on. That's the first idea that we understand when we go to school. That's the first thing we see as a skill that we can quickly acquire, trained, and then easily reproduce in mathematics. So what happens, we have these number systems called 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and on and on. It goes like this. We call this one natural numbers. Natural numbers. Why do they call it natural numbers? It's just convention that people started to realize that have different number systems. Then eventually they decided to give a name for it. So they call it natural numbers. Then next comes whole numbers. Whole numbers is just the same, but you add in the beginning 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and so on. So these are the main integer number systems that we have. We started with these are the beautiful number systems and easy to comprehend, easy to understand, and easy to memorize. And then came negative numbers. It just numbers like this, but then we start with minus numbers. So we got, let's say this is the number line. It goes on both sides. We take in the middle 0, call it 1, call it 2, call it 3, call it 4, call it 5. And then it goes on. And this side, people realized when they found out they have negative number system as well, they put on this left side. So this one is -1, -2, -3, -4, and so on. So it continues on this direction and it continues on this direction. So we just have one line of number system. You can see the left side considered as negative numbers, right side considered as positive number. And why is that? Remember, in our course or in any study, there is no such a thing as stupid question. There is no such a question which is stupid, silly, nothing like that. You can always question things and ask questions. Even your students, your classmates laugh, or your teacher laugh, or anybody laugh at you when you ask the question. Don't be afraid, laugh with them, but keep asking the question. That's the most important thing in learning, especially in science and mathematics. So they come up with this number idea. They put one line, put an arrow, puts an arrow left, right. The right side they call it 1, 2, 3, 4, 5, 6, and so on. Goes on infinity. Goes on to infinity. That means goes on and on and on. The same with this side. We got, let me write negative infinity. So it's like 8 laying down. Anyway, so you got right side, you got left side. Why is that? This is just called convention. Convention means that people made up such a left means negative side, right means positive sides. Because probably that's European system, so that's why they did it. Perhaps if the Arabians or Middle East developed number system, they read and write from right side to left side, and we read and write from left to right. So our reading goes, what is this? My pen is not working. Our reading, writing, right. I can't spell writing. All right. There you go. Writing. We start on the left side, come to the right side. But I think Jewish language, Hebrew, and Arabian language, Middle East, Arabic, they started to read on the right side to the left. So imagine their surprise when we say this is a positive side, it's a negative side. But that's a convention, that's what it means. And if you take Japanese, Chinese, they have their numbers, or reading, writing comes like this, I think, or this. So you see, each culture has its own way of developing a system. But somehow the number systems of the West Europe, because they were the first one to popularize structurally in educational systems, and this is the system that now everybody follows all over the world. And by the way, the zero is discovered or invented in India, right? Bujiam. Right, so we got this numbers progressing, army of numbers going on and on and on. And that side we got negative numbers going on and on. Right, what next? What next? You got natural numbers, you got whole numbers, that means including zero. Then we got negative numbers, that means including negative numbers, integer negative numbers. And then came the idea. It's a big story, but I will tell you next time. Then came the very, very interesting concept in number system. It's called rational numbers. Let me write here. Rational system, right? So rational number system, what it means, rational numbers, let me explain. If you take a small piece of that number line, let's say this is that piece, and we call this one 1, this place called 2, and I ask you a question, okay, this is 1, this is 2, and then it may be another piece is 3, 4, but can I cut it? Or what about number here or here or here or here or anywhere in between? What do you call that? That's a rational number system. So what it really means, you take a number, let's say 2, 3, 4, and so on, and you divide by another number, let's say 1. Let's say 1. Here also 1. So what do you get? In general terms, let's say P by Q. Both are integer numbers. These are, okay, P by Q, we call this must be integer numbers, and these two must be integer. So when you take one integer number and divide by another integer number, you get rational number. Rational number. And why do they call it a rational number? Because when you take a number, say 6, and then you divide by 2, it is called a ratio. It's called a ratio. So what it really means, a ratio means how many numbers 2 are in 6. That's what it really means. I want to ask you, I have 6 and you have 2, and then how big is my number 6 in terms of your number 2? And then what do? You got a brilliant idea to divide that 6 by 2. What do you get? You get 3, right? And this is 3. On the other hand, it's integer number, but every integer number can be divided by 3, can be divided by 1. So that means it has this p by q format. Therefore, it is a rational number. But sometimes you have a number, let's say 7. Then I ask you, how much is the 2 in terms of how many 2's are in 7, for example. Then you go with your brilliant idea. You use that idea. This 2, I got 2. I got both. I got 7 on the top. It's called nominator, denominator. You learn it later. But this 7 by 2, what do I got? 3 times 6. But then I left with 1. So point at 0 is I rand. 5 times 2, 10. So I got 3.5. This is not integer number. Not integer. So it's a decimal number. We'll learn that later. But this format is in P by Q, which is rational number. So this is a rational number because we take the ratio. That's why it's called a rational number. And then comes, if you take, right, let me erase this or this one. Good magnet. Right. This is P by Q, that is rational number. Then comes the brilliant idea, which is really, really surprising when you go to advanced studies. It is called irrational numbers. You got rational numbers, and then comes irrational number. I R R A, which is very, very important number system, which means you cannot write down, just like P by Q, which is a rational number, you cannot write down or pinpoint irrational numbers by this kind of two numbers. You take one integer on the top here and then another integer in denominator, and you try to find the ratio like this. You cannot really round it up like this. 3.5, 3.5. But here, when you divide, let's say 7, if you take square root of 7, it will come later. It will keep on going. Not going. What happened to my English? Anyway, I have to stop here. So this is called, then comes the next number system, irrational numbers. And these are the topic in chapter 1 in number system in 9th standard. What I'm going to do quickly now, so you got this idea, rough idea. We will see later on in a more long story way. For now, I just want to quickly give you some idea about number systems, and then we go to a problem solving. So just try to find out a couple of rational numbers between two integers. So this is in the book, the easy example. The question is, find 5 rational numbers between 1 and 2, like this. So you got a number, piece of numbers, line. So this is it. And let me erase this line in between, make it complete. We start with complete line without any cutting. Right, and that's almost straight. Almost. So the question is, find 5 rational numbers between 1 and 2 and write it down. How do you do that? So we know, where do you start? Step 1. We know they ask rational number. So the format is P by Q. That's the format. That's the shape, the design of a rational number. It has to be integer. It has to be integer. So we are given 1 and 2. So what do? We try to apply these numbers to this specific P and Q ratio. So I got 1, I got 2. What do? If I do like this, it's also a rational number, half. If I do 2 by 1, it's also a rational number, because you can divide any number by 1. But 2 by 1 is 2, this one. And half is a rational number. It is, let's say, half here. But they ask us 5 rational numbers between 1 and 2. Between means not including 1, not including 2. So this one not usable. And half we can, because it's in between. So that's one way of finding out rational number between 1 and 2. I got half. Why not? Using those two numbers, but it must lie between 1 and 2. So 1, 2, those are the two integers. I use those integers. I get half. Possible. What next? We need another 4. So what we can do, there's a small method, technique, which is easy one. You take the given number 1 plus the given number 2. These are the boundaries, they call it in English, but it's not really clear. But anyway, interesting thing is, you write down like this, 1 plus 2. And then you take the average. That means you divide by 2. Why we divide by 2? Why not 3? Why not 4? Because you got 1 and 2, total 2 numbers. So average means how many numbers you got on the top, count them, and then divide by it, then you get the average. That's the idea. But here, to find out a rational number between 1 and 2, we add them 1 plus 2, which is 3, and divide by 2. What do you get? We get, it's easy as pie, 3 by 2. Aha. This is in the format P by Q. Easy, right? So we got a second number, 3 by 2. It's a rational number. Rational. Aha. What next? What do you do here? We got two numbers. Why not? Between 1 and 2, half. It's not in the book, but I think it's possible. It's easy. Why not? What is the condition? Find find 5 rational numbers between 1 and 2. 1 and 2. That means it must be within this number. So I divide 1 by 2, half. It should be here. It's a rational number. Right. All right. Okay. Now we go for the fourth step. Why not writing? I have a real problem with maybe some water. Anyway, so there we go. 4. Step 4. I want to find out, okay, where is this number between this 1 and 2? 3 by 2. We have to point out here. So how do you do that? We can find out the decimal format. Probably you know, but if you don't, it's easy here. 3 by 2. To take decimal point, how many 2's are in 3? 1 time. What is left over? 1. But how many 2's are in 1? Not enough. So what do? You do point here, add a 0. How many are now? 5. So we got 5 times. So this is another rational number. It's a rational format. This is a decimal format. Now I wanted to point out where it is in this number. You see, 3 by 2, 1.5. Here is the question for you to think. 3 by 2 must come between this 1 and 2. When I see the decimal number, it says 1.5. How much we got here? From 1 to 2? Just 1, right? This is entire length is 1. But when I see the decimal point, it says it must be at 1.5. So does that mean this is 1? I got to go another 0.5 here. Think about it. It's easy, but I was surprised because someone asked me that. It's all right. It's 3 by 2. Okay, p by q, rational number, fine. When I put the decimal number point system, it comes 1.5. Between 1 and 2, I got only 1. So how am I supposed to put 1.5 between 1 in one length? Think about it. But this is really a rational number. Why? Because it's in the format p by q, nominator integer, denominator integer. So we got rational number. This is also rational number. So we got 1, 2. What about the another rational number? Let me put it here then. Next, what do we do? Suppose the number is somewhere here. It has to be between 1 and 2. Let's say I'm not specifying any place here because you have to think about it. What I'm going to do, let's say it must be between here. So that's what I put. So now the next number we can find out 2 ways. One, we can choose, because you need 2 numbers to find out rational number between these 2 numbers. So if I ask you, the next step is, what is the rational number between 1 and 3 by 2? You can do that. You can find out a number between here. Or you can choose what is the number between 2 and 3 by 2, this place. Here you can also find a number, a rational number. So what we are going to do, first we are going to find out a number between 1 and 3 by 2, and then we will find out number between 3 by 2 and 2. Let's try. Okay. Okay, so the format is 1 first number plus the second number 3 by 2, and I have to find the average. Don't make mistake here, because a lot of students make mistake here because they're in a hurry or they think it's easy. It's not. Take it easy. But here you got 1 plus 3 by 2 divided by 2. It must give you a rational number. But if it is bit confusing, I always find not confusing but not beautiful. So what I do usually, I put 1 under this number. There's nothing here, but you can divide by 1. It gives always 1. Plus 3 by 2. So this is, you see the fraction format. And then divide the entire thing by 2. So we're going to break it down in 2 steps to find this one out. First we work out this part, and then finally we divide. So let's take, so we take on the top side, we try to work out that one first. It gives the summation. So what we do here, we take for between 1 and 2, we take this 2, we need that one. And then you know how to do it, I hope. Otherwise I will explain later. But so it's 2. And now you take that denominator 2 and find out how many denominator of this one is in here. So you divide by 1, which gives you 2. And take this 2 and multiply by this number that comes here. So 2 times 1 is 2. So it goes here. Between these two numbers we got plus, so it has to be plus. And what next? Now again we take the denominator here, which is important, for 2. Then find out in this denominator how many denominator of this are in here. So that's also 2. So 2 by 2 gives you 1. You take that 1, you take this 1 and multiply by on the top, which is 3. So we got 3 there, which gives you 5 by 2. This is the first part of this calculation. So we got 5 by 2 and we have to divide this by this 2. So let me do it here. So I got 5 by 2 and this entire thing needs to be divided by 2, this one. So if you do this, you know how to do this one. So it means you take 5 by 2 and you flip this one upside down, because this 2 is down here as 1 under it. Every number, every natural number can be considered that under denominator 1. So we take these 2 by 1, flip around to multiply, because it's in division format. When you go for multiplication format, you do like this. When you flip it, and then you find out what is it, which is on the top 5, and in the denominator down, which is 4. So we got another rational number, and this number must be between these two numbers, between 1 and 3 by 2, between 1 and 3 by 2. So it is somewhere here, but where you put it, think about it. So we got half, one number, 2, I got 3 numbers. So you need 5. So 1, 2, 5 by 4 is 3. You need to find out another 2 numbers, which you can do it. It's easy, the same way. And I will continue next time with the same rational number problem solving, some examples. But now I leave you with finding out the simple rational numbers between 1 and 2. We found out here 3 numbers. 1, this one, 2, this one, rational number between 1 and 2, and then we find out the third rational number between 1 and 2. So it must be here. Here's 3 by 2 where it should come. Then you can find out rational number between 2 and 3 by 2, and from that number you take that number here, it must be somewhere here, and find out another number between here. So you will have 1, 2, 3, 4, 5, or you can keep going on and on and on, because the whole idea of this exercise is to make you realize there is no end to finding out rational numbers between any two integer numbers. So we took here 1 and 2. You can also ask, what about between 2 and 3, or 3 and 4, 5 and 4 and 5? So you can go on and on. You can always find between two integer numbers rational numbers. So next time we will take a big line here between 1 and 2, and we will plot these rational numbers between 1 and 2, and then see where those numbers land between 1 and 2. And if possible, maybe we'll go further and we will find out like 10 rational numbers, 20 rational numbers. Why not? And see how far it goes. The method is the same, easy, the same here. But this method is very, 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 very interesting and very, very, very important skill you should develop, because it will always help you. This is very important technique all the way to university mathematics, research mathematics, because people will go study advanced mathematics. What happens? Eventually they forget school mathematics because they memorize, they forget, not interested, or not enough thought put into this kind of simple things. But when they go to study more complex system, they tend to forget, including me. You won't believe, when I took this book after a long time, I couldn't find out rational number between 1 and 2. It took me for a while to realize I made mistakes too. So that says, even though you have studied in the past very, very long time ago, you have to keep up, you have to memorize, you have to work out, we have to exercise to keep them up to date. Otherwise, we will forget. So that's the message for now. Next time, I want to see if you have comments. Put it under the comment section. Find out the rest of these requirements, those 2 or 3 rational number between 1 and 2, and let me know. See you next time.